So I pointed out that we have these funny spaces for collaborative filtering. We have two types of ways of doing collaborative filtering. Um, One is so-called user-based. We're trying to find users that are near each other. So every user is a point in a space, and we're trying to find which points are near what other points in that space. And so each user is in a space of dimension n, where we have n items. And then you use a certain technology called the Pearson coefficient um, to find out which users are near each other. It's a pretty complicated space because although we have n items, any one user is a point in that space. We don't actually know exactly where they are in that space because a given user is not actually obviously has not looked at every movie. And so many of the you view this as a vector, many of the vector values correspond to particular dimensions. Nearly all of them are empty, and so you need to put that into your analysis. And that's where this issue of which particular measure of when you define a distance in this space, exactly how you do it is non-trivial because of these missing coordinates, and that's where things like the so-called Pearson coefficient come in. Another approach to collaborative filtering is item-based. You think of all your items, say all your movies in the space of a particular dimension equal to the number of users. Again, the coefficients of those vectors are probably the ratings of the user for that item. And again, every item is not rated by every user, and so most of that vector is very sparse with only a few values defined. And if we want to, if you want to find movies that are near each other, you look in that space, look at the distances between movies, and find distances which are small. And then if somebody watches a given movie, you might suggest to them they look at these other movies that are near in that space. The alternative way recommended arrangements work is to look at the user-based approach, where you take a given user, you find which other users are near that user, and look at what those other users, because those users presumably have ranked movies similarly to our given user. You find out what those other users have looked at and suggest that to your current user. So these are all approaches used. There is a third approach, which is actually probably the most obvious approach, which is so-called content-based recommender systems. And here you might say, well, I mean, let's take an example, personal example. I was choosing books for my daughter, and Amazon. I was choosing some Enid books by an author, Enid Blyton, who was suitable for her age, and obviously Amazon found books near Enid Blyton, a lot of which was other books written by the same author. So that's content based. Given an item, you find which items are similar in terms of the author, the title, the age group, the length, etc. So um, all of these different approaches, content-based, user-based, item-based, are just three ways of looking at this problem. You have to decide empirically which is the best way, or else you combine all three to look at how you get an answer from all these three methods and combine the results from those methods. A good example of a website that uses this is Pandora, which uses this for songs with the so-called music genome, which defines rigorously the content of each song. So whereas Netflix, I don't think Netflix uses the music genome for movies. Netflix uses item-based or user-based, and Pandora uses content-based recommendations. Probably they all use all recommendations now, but in the simpler world of the past, then there was sort of classification. Last.fm used collaborative filtering, and Pandora used content-based recommender systems. So this just points out the world is set in spaces. These are not real spaces. They don't have real distances, so-called Euclidean distances. and but thinking of them in a space is very powerful, and um, and you do, and it's also very useful to find effectively a distance on this space. But this distance is not like a Euclidean distance. It usually is always positive. Typically, it's symmetric, namely this means A and B equals this means B and A. That's not always true. But usually, all we have in our space is the points and some way of finding a distance, which is not trivial. I pointed out because we had missing components, it was not trivial at all. And then we come to the k nearest neighbor algorithm, which is finding the k points nearest a given point. That typically uses distances. You find all the points which are near a particular point using these distance measures. And if you look at this type of problem, you can either do it in a sort of dynamic fashion, given one point, you find the points which are near, and then you use those to make a decision. The alternative is to use some a priori division of the space into nearby points. That's what clustering does for you. That's what latent factors does, or topic modeling does. And those all are sort of pre-processing the space and dividing the space into subspaces. And you say every point in a subspace is sort of near each other, and candidates are being suggested to this particular user. So these are all intuitively reasonable approaches, which are motivated by what happens in spaces which are familiar, but applied in these complicated spaces.